Good evening, everyone. Am I audible to everyone? Hello,
Yes,
good evening. Yeah,
yes, ma'am. Now audible.
yeah. Actually, chairperson has not joined yet, and we are waiting for her. So as soon as she will join, we will start. Good evening, everyone. Am I audible?
Hello. Yeah, very good evening.
Yeah. Good evening, ma'am.
Yeah.
I am Dr. Rita Singh, Assistant Professor, Deshbandhu College. Welcome you all
Hi,
on
this is
behalf
good
of organizing committee. And the chairperson of this session is Professor Sunita Bhagat, ma'am, and she is with us now. So we will start this session. It's my great pleasure to introduce Professor Sunita Bhagat, ma'am. Professor Sunita Bhagat is from Department of Chemistry, ARST College, University of Delhi. She obtained her PhD and master's degree from University of Rajasthan, Jaipur. She has teaching and research experience of about 30 years and has published 55 research papers in various national and international journals of repute. She has authored 3 books, 3 book chapters, and filed 2 patents to her credit. Currently, she is fellow Delhi School of Public Health, Institute of Eminence, University of Delhi. She is recipient of many prestigious awards like Excellence Award for Teachers in March 2023 by University of Delhi, INSA Teacher Award in 2017, and many more. She has been awarded many research projects from DST, SERB, ICMR, and UGC. She has supervised 9 PhD students from her lab established in ARST College and is involved in many academic and research activities. She is member of many professional bodies like American Chemical Society, Organization for Women in Science for Developing World, Royal Society of Chemistry, life member of Chemical Research Society of India, life member of Indian Association of Chemistry Teachers, and many more. And last, I would like to say she was pioneer of research. She is pioneer of research work in her college and has set an example at Delhi University by carrying out research work actively in the area of natural product synthesis, fluorine chemistry, development of fluorinating resins for synthesis of fluorinating cycles of biological importance, and many more. Welcome, ma'am. And now I would like to I would like to give you the session.
Thank you, Dr. Rita. And I welcome all the participants. I hope how many participants are there? There are 13 presentations.
Yes, ma'am.
And the time limit for every presentation is 5 minutes, 5 to 7 minutes.
Ma'am, it's 8 minutes for presentation and 4 minutes for question and answer.
Okay, for question and answer. Okay.
Yes.
And is there any audience connected on this session? Do we have? Or
Yes, ma'am.
only presenters are there?
Yes,
There
ma'am.
may
Two
be
to two to three audience
two,
are
three
there.
only. Okay. So I wish you all the best. I think we can start with the very first presentation. It's by Dr. Poonam. She is faculty, as I can see in the list.
Yes.
Good
Mm,
evening, ma'am. Good evening,
good
respected
evening.
chairperson and everyone. Am I audible to you?
Yes. So you are Dr. Poonam.
Uh, yes, ma'am. I'm Dr. Poonam.
Okay.
Going
From
to
which
present
institute
my
you are?
study.
From which institute
I'm
you are?
from I'm from Panipat Institute of Engineering and Technology, Panipat.
Okay. So good to have you on this platform. I invite you for your presentation.
Thank you, ma'am. Thank you so much. I'm going to share my screen. Is my screen visible?
Yes.
Okay. Good evening, everyone. I'm Dr. Poonam Verma, from Department of Applied Science and Humanities, Panipat Institute of Engineering and Technology, Samalkha, Panipat. I'm going to present my study on the topic is fly ash and effective adsorbent for wastewater treatment. From the topic, we can say that this study is related to the wastewater treatment. So first of all, I will start from the water pollution, role of industries in water pollution, major pollutants. So as we know that water pollution is caused by the disposal of untreated pollutants from the commercial and industrial sectors. So many contaminants, sewage, domestic sewage, chemicals and fertilizers, so many sources for the water pollution. Out of which what industries plays the very important role for the water pollution. Almost 70% industrial effluents dumped in the local water bodies and rivers without prior treatment, and thus contaminating the water body supply. The major pollutants are actually complex mixture of chemicals, dyes, dissolved in suspended solids, bleaching agents, and so many things. And they affect the quality of surface water, soils, and groundwater. Out of all the major pollutants, colors, which are actually dyes, can said to be the highest pollutant because they are colored, ionizing, and complex aromatic organic compound, which has an affinity towards the fiber to which it is being applied. It is generally applied in an aqueous solution and may also be used with mordant to improve the color fastness of the dye. The problem is uh, color because it is a highly complex organic compounds. Against the natural conception of pure water, it is hide other type of pollution. As you seen in the picture, you can observe that it prevents all the it hides all the pollutants and prevents the penetration of sunlight into the layer of water and photosynthesis. These are very toxic, carcinogenic, highly stable in nature, do not degrade easily, difficult to remove by conventional water treatment methods. May cause various diseases like allergy problems, respiratory disease, contact dermatitis, asthma, vomiting, and so many. I formulated the problem that is Panipat, which is the industrial hub, and the textile industries in Panipat cities discharge large amount of dye effluent into local water system, Yamuna River, directly or indirectly, which cause water pollution. I have collected fly ash, which is also a solid byproduct from thermal power plant, Panipat. It is also a major pollutant for water and air pollution. So the aim of this study is used to fly ash, one of the solid particulate combustion product of coal ash as adsorbent material to reduce the water pollution by adsorption of dye and resultant removal of color. And I have chosen here adsorption process. Why adsorption? Because the adsorption process is economically cost effective. It is very convenient, easily operated, capable to treat industrial effluent containing high concentration of dye and has competitive performance. Here, besides all the negative negative impacts of the fly ash, there is an active field of research directed towards developing alternate use of fly ash, such as adsorption of water pollutants like colors, heavy metals, and other unwanted materials. Fly ash used in this study is collected in bulk amount from thermal power plant Panipat free of cost. Chemical composition of fly ash is characterized at Medchem Laboratories, Vadodara, Gujarat, and the composition is expressed in oxides form. From the composition study, this fly ash is classified into class F fly ash because it has calcium oxide below than less percent and silicon oxide is higher than 50%. Methodology used in the study is, first of all, fly ash, the binding sites of fly ash is activated with the H2SO4 to enhance its adsorption property. The adsorbent, that is activated fly ash, was characterized before and after the adsorption process with SAM, XRD, and FTIR techniques. Adsorbate material, that is pollutant, we have collected two types of dyes. First is reactive red 194 dye and second is reactive orange 107 dye. The batch mode adsorption process is used in this study. The effect of mixing time, adsorbent doses, initial dye concentration, and pH by absorption of reactive red 194 and reactive orange 107 dye from the effluent sample alpha under the equilibrium condition were investigated using batch mode experiment at room temperature. Dye solution have taken 50 milligram per liter, were stirred on electronic magnetic stirrer with fixed pH and agitation speed of 500 RPM. The equilibrium, that is final concentration, were measured using UV visible spectrophotometer as maximum absorbance value after each treatment. Langer and Friendly isotherm model were used to fit and compare the adsorption data. Here is the characteristic properties of both the dyes. Now, result and discussion. From the interpretation of FTI spectra of alpha means acid activated fly ash and reactive dyes loaded alpha. From the FTIR spectra for the both dyes, we can say that all the bands appeared after the adsorption are shifted either lower or higher frequencies from their original frequencies as a function of chemical interaction of the reactive red 194 dyes with alpha. Here, black line shows the raw fly ash alpha and red line represents the dye loaded fly ash. XRD characterization. From the XRD characterization for both the dyes, we observed that the peak of reactive red 194 dye loaded alpha were slightly shifted towards the higher angle with respect to silica phase when compared to the XRD of pure alpha before adsorption. And the peak obtained for RO1 reactive orange 107 dye loaded alpha are slightly shifted lower angle with reference to the silica phase when compared to the XRD pure alpha before adsorption. SAM characterization. With the SAM photograph or image clearly shows that fly ash particles are irregular in shape and porous in nature. But after the adsorption of both the dyes, the pore and surface of alpha were completely packed and covered with the dye and become densely packed. Here is the result for the different parameters. Like first parameter is pH, effect of pH on adsorption equilibrium. The adjustment of pH was done by using 0.1 normal HCl and 0.1 normal NaOH. In case of reactive red dye, the adsorption pH solution increases from 2 to 9 and percentage of dye removal. Sorry. Percentage of dye removal and quantity of dye adsorbed also increases, whereas the quantity adsorbed and removal rate for both the dye increases as pH of the solution increases for 2 to 4. Maximum adsorption observed in acidic medium. Effect of mixing time on adsorption equilibrium. As we say that from both the graph, the adsorption rate is fast initially due to large surface area of alpha being available. With the passage of time, the surface active site of alpha decline and the process of adsorption of dye is controlled by the slow movement of dye molecules posterior to interior sites. Percentage adsorption increases up to 300 minutes for reactive red dye and to 10 minutes for reactive orange dye. However, maximum removal takes place during first 180 minutes. Next is effect of adsorbent doses on adsorption. So from the both the diagram, both the graph, we can say that percentage removal of both reactive dyes increases with increasing the doses of adsorbent. However, quantity adsorbed dye per gram of adsorbent decreases because the number of heterogeneous sites increases and the amount of quantity adsorbed per unit of adsorbent decreases. The optimum concentration of adsorbent dose found to be 85 gram per liter for reactive red and 35 gram per liter for reactive orange dye for the maximum removal. And next parameter is initial dye concentration. Initial dye concentration, as the concentration increases, the quantity of dye adsorbed per unit mass of adsorbent increases, but there is a decrease in the percentage of dye removal. Here the adsorption isotherms used are Langmuir and Freundlich isotherm model because it indicates the adsorbent molecule distributes between the liquid phase and solid phase when the adsorption process achieves an equilibrium state. Langmuir adsorption shows the effective monolayer adsorption on homogeneous adsorbent surface having finite number of active sites and energetically constant. It also estimates the maximum adsorption capacity obtained from complete monolayer coverage on adsorbent surface. The linear graph or plot of C upon Q against C confirms that linear isotherm model is suitable for explaining the adsorption process. It will be explained by the next slide with the graph. And here also dimensionless equilibrium parameter, that is RL, is used to express the essential characteristics of Langmuir isotherm. When the value of RL is greater than 1, then adsorption is unfavorable. If the value of RL is 1, then adsorption is linear. But when the value of adsorption is 0 or 1, in between the 0 to 1, then adsorption is favorable and irreversible when RL value is 0. Freundlich adsorption isotherm is also used for the study. And here is the graph for the Langmuir adsorption isotherm and Freundlich adsorption isotherm. From this study, we can observe that Langmuir adsorption isotherm is more suitable and more favorable for the adsorption of reactive dyes on alpha as compared to Freundlich isotherm. From the table, you can say that the maximum adsorption capacity in case of Langmuir isotherm for reactive red dye is 47.17 milligram per gram, and for reactive orange is 94.61 milligram per gram. Whereas in Freundlich isotherm, it is only 2.8 and 2.1 respectively. The conclusion is FTIR mix RD-SAM shows clear adsorption of dyes onto alpha. Alpha showed better adsorption capacity in acidic pH range for all the reactive dyes. The percentage of dyes removal and quantity of dye adsorbed per unit mass of adsorbent increased when increasing the mixing time, but after a certain period, it reaches to saturation point or equilibrium point. The percentage of dye removal increased with increase in adsorbent doses, but amount of dye adsorbed per unit mass of adsorbent decreased on increasing the adsorbent dose. As the initial concentration of dyes increases from 10 to...
Please stick to time.
Miss, I will finish, ma'am. Just a minute. Here is the result. We can calculate. We are calculating here experimental correlation coefficient R square value of Langmuir and Freundlich isotherm model. And for reactive orange, it will be 0.99 for Langmuir isotherm and 0.96 for the reactive orange. In case of friendly, it will be 0.8 and 0.9. So from this data, we can say that Langmuir isotherm model is more suitable and more favorable for the absorption of dyes. Here is the result. From this table, we can represent the result of reactive red and reactive orange dye. And all these studies, from all the studies, we can conclude that acid activated fly ash, that is AFA, is an efficient adsorbent, and being a byproduct of industry or pollutant, as a pollutant, it is very easily available and economical. Thank you.
So, Dr. Poonam?
Yes, ma'am.
Yeah. So, any question from audience? Any question from audience? No. So, Dr. Poonam, it was nice, good piece of work, and all studies you have done, that is basically in water sample taking different
Yes,
parts.
ma'am. I have
Yeah.
taken water sample from Panipat textile industries and
Okay.
also taken fly ash from thermal power plant Panipat.
Thermal plant. Okay, okay.
Yes, yes,
No
yes,
other
sir.
places have been covered.
No, ma'am. I have
Okay.
taken, but because Panipat is an industrial hub, here
Yes.
water pollution is much more than
Yes.
the other
Right,
states.
right.
Yes,
So,
yes, yes.
my one question to you is that
Yes, ma'am.
I just could not get from your presentation that what is the novelty of your work, means how it's better, different from the other work which has been done.
Ma'am, actually, from the earlier studies, fly ash has been used for so many work, but used with the blended mode,
Okay.
used with the other adsorbent. But I have chosen here only fly ash, and
Okay.
its active sites is activated with the acid.
Okay, okay. Thank you, Dr. Poonam.
Thank you so much, ma'am. Thank you.
So our next participant is.
Can I leave the meeting, ma'am?
Yeah, you may leave the meeting. If you are interested, you are most welcome to stay and listen to the other participants. It will be encouraging for them as well.
Thank you so much, ma'am. Thank you.
Okay. So next is Dr. Mr. Atul and Aarti Sharma.
Yes, ma'am.
Okay. Yes, Dr. Aarti. Good to have you on this platform.
Thank you, ma'am.
In fact, I am not having the title of your presentation. So it's better if you tell yourself what is the title of your presentation. That would be great.
Okay, ma'am.
From
Just
which
one second.
institute you are and what is the title of your presentation. Okay.
Good afternoon to everyone, respected chairperson. I'm Aarti Sharma. I'm the assistant professor of chemistry in Government College, Jogendranagar. It is located in district Mandi of Himachal Pradesh.
Good.
Can I start, ma'am? I'm
Yeah,
sharing my
you may please go ahead, and time limit, it's 7 to 8 minutes, please.
Okay, ma'am.
Please stick to time.
The title of my paper is Synthesis of Biodegradable Polymers and Their Sustainability in Human Life. This is just an outline of my presentation, which includes introduction, comparison of natural polymers with the synthetic polymers, then the introduction of biodegradable polymers, then polysaccharides as biopolymer, their biological and chemical properties, chemical modification of these polymers, and the copolymerization of the biopolymer, and their application as the sustainability in the human life. So first I will start with the introduction of the polymers. The history of polymer is as old as human civilization all over the earth. Polymers have been widely used by human beings in the form of the cotton, protein, sugars, wood. And human body itself is a representation of collection of many polymers like protein, nucleic acid, skin, hair, glycogen. These all are called as polymer because they consist of a cord of similar repeating units. And there are many novel polymers which have been synthesized and modified in the laboratories. Here's a chart which shows the natural polymers, which mainly has two natural polymers, proteins and polysaccharides. Now moving to the comparison of natural polymers and synthetic polymers. With the evolution of the civilization, polymers have also been adapted to increase their utility with the creation of synthetic polymers in addition to the polymers which are already present in the nature. Many polymers have been synthesized and modified in the laboratories, and the research is going on in this field. So natural polymers have one biggest advantage over the synthetic polymers because they are less expensive, non-toxic, renewable, freely available, and they are benign to the mammalian tissues as they are made from the living organisms. However, the synthetic polymers are prepared in the laboratories and their effect on living beings are unknown for the long term. It is just a picture during the field visit with my polymer students. This is the collection of natural rubber or latex at a forest in our area. Now the question comes that why shall we synthesize polymers? Because they are most useful and the important materials which are present on the earth. Presently, they are used right from the cradle up to the pyre in human lives. They have very good physical properties, chemical properties, and economical properties, which make them durable, mechanically strong, multifunctional, easily available, and cost-effective. So they add significant to the comfort and the quality of our life. These are the uses of polymers in the various fields, in the medicine, in our everyday life, agriculture, as well as industry. So here comes the biodegradable polymers. The disposal of the polymers after their use is the biggest concern these days. So polymers can be differentiated on the basis of their disintegration. So biodegradable polymers are those class of polymers which can be disintegrated into the non-toxic products by the use of the microorganisms. And non-biodegradable polymers are a threat to the environment. As we all know that the plastic litter is the biggest problem these days. So the first known natural polymer or the biopolymer are the polysaccharides, which are the condensation product of monosaccharide units, and they form the linear chains which are linked through glycosidic linkages. They are the unique raw materials because they are abundantly present in nature, and their products and their properties can be modified easily. They are biodegradable, hydrophilic, and non-toxic, and the presence of large number of functional group and their high chemical reactivity and flexible structure of the polymer chain results in having the high hydrophilicity of the polymer, and it has an excellent adsorption behavior. Polysaccharides can be modified by inserting some other molecules into the long polymeric chain to attain the modified polymer with the additional properties. So the different methods which can be used for the chemical modification are cross-linking, grafting, blending, etc. of the polymers. First method is the cross-linking. It is the multidirectional chain extension of the polymers, which leads to the formation of network structure, and it leads to the formation of the bonds between the polymer chains in cross-linking. Vulcanization of the rubber is an example of the cross-linking. into the natural polymers, generally the biosaccharide. And the graft copolymer is a blend of the properties of the parent polymer, and it is designated as specialty polymers with the improved
Aarti, your
physical and
screen is not visible now. You were missed in between also. It's fine now.
Is it okay, ma'am?
Okay, start from this slide number 16.
So there are various methods of grafting, which includes, first is the chemical method of grafting, in which we can use a free radical chemical grafting method that will be used during the formation of the copolymers of polysaccharides with vinyl alcohol. The second one is the radiation method of grafting, in which grafting of vinyl monomers onto polymeric backbone will be done by employing the UV and high gamma radiations. So the purpose of our study is to prepare the copolymers by polysaccharides and vinyl alcohol. This is very helpful in improving their physical strength and chemical reactivity. The copolymers can be further modified by grafting to widen their spectrum of applicability. For the present study, we have selected the polymer substrate. For this, we have selected polysaccharide, chitosan, and carrageenan. They are used along with the biocompatible polymer PVA, polyvinyl alcohol. They all have very unique chemical and biological properties, and they are biocompatible as well as biodegradable. This is the structure of the chitosan, which is a polysaccharide, and this is carrageenan. And the purpose of our study is the sustainability of that biopolymer in the human life, because the natural polymer have inherent biological and chemical properties which determine their biological activity and are used in various applications, including food, pharmaceutical, biomedical, and other industrial applications. Therefore, the polysaccharides and polysaccharide-based polymers are foreseen to confront the challenge of global sustainability. And the prime objective of our study is to synthesize these environment-sensitive and economically attractive modified copolymers using natural polymers chitosan and carrageenan and a synthetic polymer PVA, which is also biodegradable. The synthesized copolymers have potential technological interest because of being biodegradable, biocompatible, highly hydrophilic, and they are as well non-toxic in the nature.
So, Dr. Aarti, good to hear you. Your work is on, synthesis of biodegradable polymer. What is the success rate? Means, how do you assess your work? Means, your achievements in respect to what work has been head of what has been done.
Actually, this is the work of Dr. Atul. Due to some emergent situation, he could not present this work. So I'm presenting on his behalf. He has already completed his doctorate for the synthesis of biopolymer of chitosan and carrageenan with the polyvinyl alcohol.
Okay. And I was wondering, has this work been published somewhere?
Ma'am, some of the papers have already been published.
You have not mentioned any of the publication here?
I haven't mentioned here, but there are 3 publications.
Yeah, so my advice to you is that you should at least include whatever the publications are out of this work. You should
Okay, ma'am.
include in this. Okay, wish you all the best.
Sure, ma'am.
Yeah, wish you all the best.
Thank you so much, ma'am.
Good presentation. Okay, so let's all thank Dr. Aarti for her wonderful presentation. Now the next presentation is by Dr. Narendra Singh. Sorry, Dr. Ankita. Dr. Ankita?
Yes, good evening, ma'am.
Yeah, good evening. Your title of talk is, yeah. May I request you to please give your title of talk and introduce yourself? That would be great.
Yes, ma'am. Can I start my presentation now?
Yeah, please go ahead. Okay, welcome on this platform.
Is my screen visible, ma'am?
Yes, it's fine now.
So I'm good evening, everyone. I'm Dr. Ankita, Assistant Professor in Gurugram University. And the title of my paper is Analysis of Physico-Chemical Properties of Drug Betaine Hydrochloride in Aqueous Carbohydrate Solutions at Different Temperatures. So wherein we have calculated the physico-chemical properties of the drug in aqueous solutions. So first we'll be moving on to the introduction part. See, the solution chemistry, discovery of the solution chemistry, that dates back to the early part of the 19th century. That with the discovery of various laws like Raoult's law, osmotic pressures was discovered by Jacob Van 't Hoff. So all these these properties were calculated from the various 19th century. Then comes the application part. The application of this, the data that we have derived, that is the physico-chemical data, is useful for various biochemical and physiological processes like protein hydration, denaturation, aggregation, in case of amino acids and peptides. While in case of surfactants, this is used for in the process of methylation and for various other biological applications like targeted drug deliveries. Then it is used in polymers also for studying the polymer phase studies. And in case of biotechnology, it is used for separation and purification processes. It is used in medical, in pharmaceutical, cosmetics, and pesticides industries. So these are some of the applications of that.
Your screen has disappeared.
Ma'am, is it now visible?
No.
Is it visible now, ma'am?
No. At least not to me. If anyone can see, please let me know. Dr. Rita, can you see that?
Yeah, no, ma'am, it's not visible.
Okay.
Ma'am, I'm trying, just a minute. Is it visible now, ma'am?
Yeah, it's fine now. Okay.
So why are we using drugs then? We are studying drugs because it has a very importance in by knowing their solution behavior in our physiological action of the drugs within the living beings. Then the thermodynamic properties of the drugs is important to understand the drug solvent interactions and the drug action at the molecular level. Then various specific and electrostatic interactions are also studied using these drugs. Then we have studied about the carbohydrates, and as all of you know that carbohydrates is the most abundant class of the organic compounds, and this is present in our living system as well. So this is of great subject of interest because of its physical and biomedical and industrial properties. Glucose being the primary fuel in the body that is required for the energy to carry out the cellular activities. Now, why are we studying the drug macromolecular interactions? Macromolecular means the carbohydrates to the carbohydrates, we have called it macromolecular here. First of all, these interactions are really complex in nature, so they are difficult to study. So knowing these physicochemical and thermodynamic study, we can understand the pattern of the drug macromolecular interactions through these values, and also how they are temperature dependent, as well as how the concentration effect can be studied through these measurements. So various properties like volumetric, viscometric, and acoustic properties are helpful in understanding these interactions. The system that we have studied for the present work is betaine hydrochloride, and we have studied that in the chosen system were D-xylose and arabinose in water. Now, various 5% and 10% solutions were made for xylose and arabinose and the drugs which was used, that was betaine hydrochloride, was taken at different molalities. Now, at different molalities and various temperatures, the concerned properties that we studied were density and ultrasonic speeds. Now, why have we chosen betaine is because it is important, as it is used as a supplement for low stomach acid. That is, it is used as a digestive pill, and it's also used for treatment of various food allergies like thyroid disorder, diarrhea, and various other things. Now, the methodology that we used was, first we prepared different molar solutions of the drug in different carbohydrate solutions, that is xylose and arabinose, and by using using triply distilled water, which had conductivity of 1 × 10⁻⁻⁶ centimeter inverse. Then the density and ultrasonic speed measurements were done using DSA 5000M, that is density digital vibrating tube density and sound analyzer. And its instrument, through this instrument, both of these quantities were measured with great reproducibility and uncertainty factors. Now, from these values, various analysis of the density and ultrasonic data, various derived parameters were calculated, like apparent molar volume, limiting apparent molar volume, transfer volume, and the compressibilities in the same ranges. Now, through these properties also, we calculated one another property, that is apparent specific volume, which gives an idea about the taste quality of the drug, whatever we are using in different solutions that we have taken. Now, the first one is how when we studied the variation of apparent molar volume with concentration of betaine hydrochloride in aqueous xylose arabinose solution. Now, through this, through the interpretation of this graph, as we can see that this is the graph of apparent molar volume with respect to the molalities of the solution of the drug. So the drugs of different molar solutions were prepared and in 5% and 10% xylose and arabinose solutions. And this is the graph that we found out. What we found out through this graph was that as the concentration of the carbohydrate solution increases, the apparent molar volumes also was found to increase. And also with respect to temperature also, these values were found to rise. The reason for this was that as the temperature increased, the solvent molecules that were present in the loose solvation cell of the ionic and the hydrophilic groups of the drug betaine hydrochloride, they got released into the bulk of the solvent, and which resulted in the expansion of solution. So the molar volume that it should have been, with rise of temperature, this value of these molar volumes increased, and that's why which was reflected in the graphs. And this also shows that there are the interactions that are ionic hydrophilic interactions and hydrophilic interactions. They increase with the increase in the concentration of the solute. So the graphs of various temperatures and with respect to the concentrations also were found to increase. This graph here depicts the values as the temperature rises. The next variation was of the apparent molar compressibility with the molality of betaine hydrochloride. So the Ks5 denotes the apparent molar compressibility, and the molar solutions were found to increase. Now, in this case, as the Ks5 values are negative, so as with the rise in temperature, the values become less in magnitude, but due to the negative sign, the values therefore are increasing with respect to the concentration. Now, again, with the temperature, these values were found to rise. Because addition of carbohydrates leads to reduction of cavities in the solution, as some of the water molecules are released in the bulk water, making the solution more compressible. So the compressibility is also increases as the temperature of the solution rises. As they become more compressible, so that indicates that there are some strong attractive interactions within the solution. Now, these are some properties of limiting apparent molar volumes, which is denoted by V phi naught. And then this is the sigma. Sigma is the standard deviation, and this is SV. So limiting apparent molar volumes, as you can see, it is the molar volume at infinite dilution. At infinite dilution, there are no solute interactions that are present, but only solute solvent interactions. So as you can see that in water, in 5% xylose solution, 10% xylose, as we compare these solution this data, we can see that on increasing the concentration, these values were found to increase. As these values increase, we can see that the solute solvent interactions are also increasing. While a very less values, these SV values denote the interactions constants, basically of the graphs that we have plotted, and this constant, this denotes about the solute interactions.
Dr.
So
Ankita, you are exceeding time, please.
yes, ma'am.
Okay.
So as the constant, you can see that these values are very less. That means there are minimum interactions in the solution of the solute interactions. Similar, you can see for the Ks5, in 5% aqueous solution, xylose solution, and 10% xylose solution, the known to increase with respect to the, as compared to the water solution. So in the conclusion, we can say that the various parameters of both this indicate the presence of strong solute-solvent interactions and weak solute-solute interactions between the drug and the solvent molecules. So these interactions therefore increase in concentration of the carbohydrates as well as with the temperature, which were helpful in understanding various aspects of the drug action in the biological system in aqueous medium. Thank you, ma'am.
So, any question from the audience? Anyone, please? Okay, so Dr. Ankita, so you are there as the, completed PhD or working for PhD?
Yes, ma'am. I've completed my PhD from DU itself.
Okay, okay. And this standardization process which you have carried out, is this, based on some literature survey or you have done it yourself?
Yes, ma'am. It is based on the literature survey. We have seen the various properties which were already taken out. So out of that, we have taken out those properties which were not at all studied before.
Okay, okay. And any changes in the, the standardization process from the previous literature which you have made?
Yes, ma'am. I have calculated the values because it is all theoretical calculation. So I have calculated the taste behavior of the drug. So
Okay.
my calculation, I found out that this drug is bitter in taste through the ranges of the apparent specific volume.
Okay.
So it's not found out later.
That's good. So good piece of work. Let's give big hand to Dr. Ankita. Thank you, Dr. Ankita. Okay. So now we have Dr. Narendra Singh. He's also faculty at Dr. Narendra Singh. Is he there?
Ma'am, he is not there.
He's not there.
He has not joined us yet.
Okay. So next is Dr. Chaya. Dr. Chaya, are you there?
Yes, ma'am.
Yeah. So Dr. Chaya, welcome to this platform organized by ICHE, and I request you to please introduce yourself, from which place you are and what kind of work you are doing. Okay, doing. And secondly, you know the time limit. Please do not exceed this time. Okay.
Okay, ma'am. I'm sharing my screen share.
Yeah.
Is it visible, ma'am?
Not yet.
Now it's, I hope.
Yeah. Yes, it's fine now. Okay.
Myself is Dr. Chaya. Yeah, myself is Dr. Chaya, Assistant Professor from Department of Chemistry, Baku College, University of Mysore, Karnataka. My topic is surface adsorptivity studies and dietary fiber determination of nanocrystals. Well, some of the adsorption techniques for removal of dyes we have used, and also for encapsulation of materials, that means electro-rheological fluids and also composite materials, and also for nano containers, and also encapsulation of dosage forms. Well, we have used adsorption process, which is a rapid, and adsorbents gradually adsorbs here dye color, or else better adsorption property. We have used cellulose fiber reinforcement. Here some of the nutraceutical material, particularly coriander, we have used. Different objectives for physicochemical parameters. Some of the materials and methods, well, bioadsorbents, mainly plant origin spent, we have used. This is the plant profile, whereas coriander seed, which is a rich components of linalool, granulyl acetate, and terpinol, and also this coming to surface adsorption and also dietary fiber determination. We have used experimental part, alkaline hydrolysis of nanocellulose amorphous powder with 18% NaOH. We will get the fiber alpha cellulose in a commercial grade. That means amorphous nanocrystals that we will adjusted further for a funnel furnace, and also in CFSC filtration. We will use the two proteins, that is pepsin and also the enzyme alpha amylase for digestion of proteins. Further, the characterization by DLS, that means dynamic light scattering, and also this graph shows particularly the nanocrystals will be very good, and also zeta average will be 613. That means below 0.5 it will be very good to optoelectronic devices and other electronics devices. That's why this nanocrystals will be wide applications. Coming to dietary fiber determination, we have calculated the coriander nanocrystals with the crucible. We will get percentage of fiber will be 54 to 53%. So it will be a good nanocrystals we have got. Out of 100%, we got cellulose nanocrystals. Some of the spectrophotometric assay we will continue with nanocrystals using temperature controlled orbital incubator and also spectrophotometer with some of the dyes. These are the some of the papers with nutraceutical. This is another Pterocarpus marsupium spen. This is the some of the characterization, SAM and also FTIR. This is the that means a raw material of coriander seed. Further, commercial grade nanocrystals we have used. That has wide applications in optoelectronic devices and also further microfilm devices like the tin films. Some of the results with concentration versus that graphs kinetics and also with pH, and also this nanocrystals will show pseudo second order kinetics. That means already we have with the encapsulation of capsules also we have tried in that time first order reactions we will got the results, whereas pseudo second order means one adsorbent will more than the other one adsorbate and adsorbent. So these are the some of the kinetic drops. We will get almost EA will be activation energy per cal will be 38.16 with different concentrations. So coming to optimum effective removal of color and also in encapsulation of dosage forms with capsules, adsorption design have firm ground and rapid impact on addition of surfaces, encapsulation, and also this nanocrystals have wide application in removal of colorants also. So this will finally depend on FTIR and SEM characterization, which confirm the adsorption process is effective. And this are some of the application form. We have got some means publication also using nutraceutical spends. And also coming to conclusion, adsorption experiments conducted as per our research methodology, the assessment of dye binding on the adsorbent surface and also removal, and also in encapsulation of surface deposition of dye shows very good favorable and also surface treatment. I thankful to my guide, Dr. Professor Syed Akil Ahmad, and also the director, Bhati College, and also chemistry department. And also I thankful to the international conference organizers for giving me opportunity to explore my research work. Thank you. Yes, ma'am.
Yeah. So Dr. Chaya, it was
Yes.
very crisp and to the point presentation.
Yes, ma'am.
Congratulations. Well done. You have done good piece of work. Any questions from the audience? Any questions from the audience? Okay, just one small question. How do we define this surface absorptivity?
Ma'am, we have used adsorbent that is widely abundant in usually coriander seed.
Okay.
It was used in nutraceuticals supplements also for energy drinks and other.
Okay.
That in some cases in dietary also they have given for supplements for diabetes, lower the diabetes and some diseases. So apart from we have used for coriander seed as for nanocrystals also in the synthesis of nanocrystals using alkaline hydrolysis, enzyme hydrolysis, and also acid hydrolysis. We will get finally fine powdered of nanocrystals, which will be wide applications in optoelectronics and also in thin film composites and also in thin films using for devices.
Okay.
Sensors activities also it is widely useful. So my topic is surface absorptivity or studies of nanocrystals.
Okay. Any other, substrate you have tried along with this coriander?
Yes, ma'am. Pterocorpus marsupium, that is a well-known Indian Malabar tree, we will say. For colorants removal, we have used. For
Okay.
nanocrystals, still we have to experiment we have to do. For the research have to do.
Okay. Okay. Good. Thank you so much. Thank you, Dr. Chaya.
Thank you, ma'am.
So let's all give a big hand for Dr. Chaya. Thank you so much. Then we have our next candidate, Dr. Gajendra Singh.
Yes, ma'am. It's audible?
Dr. Gajendra Singh?
Yes, ma'am.
Okay.
Yeah.
Welcome, Dr. Gajendra, on this platform.
Thank you.
Yeah, please introduce yourself.
So myself, Dr. Gajendra Singh, and currently I'm working as an assistant professor at the Department of Biotechnology at Central University of Rajasthan.
Central University of
Rajasthan.
Rajasthan. Okay.
Yeah.
Welcome on this platform, and please
Thank you.
go ahead with your presentation.
Yeah.
And your area of specialization is?
So basically, I'm working on peptide and peptide-based drug designing and PTMs using the mass spec and NMR spectroscopy. Also, the ubiquitinations, uh, exploration of a different kind of ubiquitination E3 ligases, looking at the detail of exploiting the E3 ligase against the cancer cell using the Protect technology. So I'm working in the diversity.
Okay. Okay.
Yeah.
Please go ahead. Okay.
So thank you, first of all, organizers for conducting this wonderful conference and giving the opportunity to present our work. So today I will talk about the beta gamma fusion structures and how these structures are, how these peptides, they having the beta gamma fusion structure are important for drug designing. So we know that there are different type of turns present in the peptides as well as in the proteins, including from the alpha turns, beta turns, gamma turns, and the delta and pi turns based on their how they are forming the hydrogen bonding from carbonyl to hydrogen and how they are connected to the uh, the number of the atoms involved in the formation of the bond. So the beta and gamma turns are basically not much evident and reported in the small molecules, basically in the fused forms. So the work is basically started with the gramicidine. As you know that the gramicidine is a antibiotic, and we cannot use the gramicidine in the intravenously because of its hemolytic activity. So in the collaboration with the Professor T.K. Chakravarti, ISC, what we did basically, we remove this proline and this phenyl with the sugar amino acids. And then further we did some of the structure, we synthesized different type of molecules by varying the R group basically on the ornithine residue, and the different R groups are basically where they are deprotected from and protected from the nocile and then the CBG group. And further, we did the NMR based confirmation studies
You're not audible. Dr. Gajen, you are not audible. I think there is some server issue. Dr. Rita, I hope he's joining back.
Yes, ma'am. Can we have next presentation? If he
Let's
will
wait for
join,
a
then
minute. Let's wait for a minute.
okay.
Dr. Rita, I think I should go ahead with the second one, next one.
Yes, ma'am. Yes, ma'am.
So if he joins, then he can be, given chance later on.
Yes.
Okay. So since Dr. Gajen could not be, was not able to continue, I invite Dr. Amar to give his presentation. Yes, Dr. Amar, please introduce yourself. Welcome on this platform.
Good evening, ma'am.
Yes, good evening.
Ma'am, I was your student in MSc.
Oh, great. That's
It's
great. Good to
good
connect.
to see you after such a long time, ma'am.
Okay. So,
Presently,
teachers are always happy to see, students growing at different places. So, proud moment for me. Okay. So, please go ahead with the.
okay, ma'am. Just a minute. Yeah. So myself, Dr. Amar Kumar, Assistant Professor in Ramakrishna Dwarka Mahavidyalaya, Patliputra University, Patna. First of all, I would like to just a minute. First of all, I would like to thank organizers of ICHE 2023 for giving me an opportunity to present my work. The topic of the presentation is plant-mediated synthesis of zinc oxide nanoparticles and their use in environmental remediation. The outline of my presentation is as follows. First, there is an introduction to nanoparticles, then synthesis, general discussion on synthesis of nanoparticle with an emphasis on plant-mediated processes. Then afterwards, characterization, a general discussion on characterization of green synthesized nanoparticles and application of green synthesized nanoparticles in environmental remediation, and why we have chosen zinc oxide nanoparticles over other nanoparticles, and our work on zinc oxide nanoparticles, which has been divided into three parts: synthesis, characterization, and application parts. So nanoparticles are typically defined as particles with dimensions ranging from 1 to 100 nanometers. They are extremely small and often consist of only a few hundred atoms or molecules. To put that size in perspective, we can compare it with a strand of human hair that is approximately 80,000 to 1 lakh nanometers wide, or a strand of human DNA, which is approximately 2.5 nanometers in diameter. Historically speaking, we see a number of early evidences of nanoparticles in use as early as in 4th century, such as Lycurgus cup, a 4th century Roman glass cup that changes color when light hits it. The cup is made of glass that contains gold and silver nanoparticles. When light hits the nanoparticles, it is scattered in different directions, giving the cup its unique color changing properties. Another early example of nanotechnology is Damascus blade, a type of sword that was produced in the Middle East from the 11th to 18th centuries. Damascus blades are known for the sharp edges and resilience. They are made of steel that contains carbon nanotubes, which are tiny tubes of carbon atoms. The carbon nanotubes make this steel stronger and more durable. At that time, the reason behind these extraordinary properties were not known. In the 20th century, nanotechnology began to be developed more systematically. In 1959, Richard Feynman, a Nobel laureate, gave a famous lecture titled "There's Plenty of Room at the Bottom" at Caltech, in which he described the possibility of manipulating matter at the atomic and molecular scale. In the 1980s, the term nanotechnology was coined by Norio Taniguchi to describe the manipulation of matter with a precision of 1 nanometer. Now, nanoparticles have unique properties because of their small size and high surface area. When materials are reduced to the nanoscale, their properties can change dramatically. This is because quantum effects and surface effects become more important at nanoscale. Quantum effects are phenomena that only occur at very small scales. At the nanoscale, the electrons in a material can be confined to a specific energy levels. This can lead to changes in the optical, electrical, and magnetic properties of the material. Surface effects are also important at the nanoscale. A nanoparticle has a much higher surface area to volume ratio than a bulk material. This means that a larger fraction of atoms in a nanoparticles are located on the surface. Surface atoms have different chemical and physical properties as compared to the bulk atoms. There are two main approaches to nanoparticle synthesis. The first one is top-down and the second one is bottom-up. Top-down synthesis involves breaking down larger materials into smaller nanoparticles. This can be done during a variety of using a variety of methods such as milling, grinding, and laser ablation. Bottom-up synthesis involves building nanoparticles from the atom or molecular level. This can be done using chemical and physical methods as well as biological methods. Biological methods, however, has several advantages over chemical and physical method because they are eco-friendly, cost-effective, simple and scalable, biocompatible, and often gives high-quality nanoparticles. Now, out of the biological methods that are used in the synthesis of nanoparticles, the use of bacteria, fungi, algae, or yeast or virus requires a certain amount of expertise, and they are relatively difficult to control. You need some special technique or something background study before using this type of precursors, biological precursors. And also some of them are pathogens and they are harmful to, and you need very much precaution to use this type of biological precursors. Whereas plant-mediated synthesis of nanoparticles are easy to work upon, cost-effective, environmentally friendly, safe, give high yields, and are scalable. Now, coming on to the characterization of nanoparticles, characterization of nanoparticles is important and are characterized with respect to various parameters such as size, shape, composition, morphology, etc. And there are various techniques used to characterize nanoparticles. Some spectroscopic and some other are non-spectroscopic techniques as shown in this slide. And different techniques give you different information and that is why you need an array of techniques, characterization techniques to characterize a nanoparticle. Now, of the many uses of nanoparticles that are being explored, environmental remediation is one of the most important. Nanoparticles are being used as photocatalysts to remove pollutant from water, as antibacterial agents to remove pathogens, as effective solvents to remove heavy metals from soil, as catalysts to promote degradation of toxic chemicals, etc. One of the major concerns of using nanoparticles is their potential harmful effects on environment and living beings. And these effects are not explored in detail because this is a relatively new area and more work is required to fully understand the toxic and other biological effects of nanoparticles. A typical production line, if you see that as described in this slide, has many areas where nanoparticles can leak into the environment. To minimize this, we have to choose reaction methodologies and choice of reagents which are relatively safe and does not produce undesirable products. Now, we have zinc oxide nanoparticles offers a lot of advantage both in terms of synthesis as well as in terms of application. Synthesis of zinc oxide nanoparticles can be achieved by using very cheap, non-toxic, easy-to-use precursors and through a variety of environmental friendly procedures. Also, synthesized zinc oxide nanoparticles are shown to be relatively safe and biocompatible. Zinc oxide nanoparticles have been used for a variety of applications, including environmental, biological, and industrial application, as shown in the slide. Now, we have been working on this zinc oxide nanoparticles and published few papers on this. Basically, we are working on two aspects. For first is this photocatalytic properties of biologically synthesized nanoparticles, and the second part is to study the antibacterial properties of zinc oxide nanoparticles. So, as discussed before, the aim of our study was to study the photocatalytic effect of synthesized and coated calcium-coated zinc oxide nanoparticles and their photodegradation and antibacterial studies. And the methodology we chose to first is the synthesis of the required nanoparticles, and then characterization of the synthesized nanoparticles, then photodegradation studies, antibacterial studies, and result and conclusion. So, the biological precursor we used in the synthesis of zinc oxide nanoparticles were cucumber juice, potato starch, agro waste such as orange peel, lemon peel, pumpkin seeds and peels, and beetroot extract. Whereas the chemical precursors that were used in the synthesis of zinc oxide nanoparticles is the zinc acetate dihydrate and calcium chloride and sodium hydroxide. The procedure is very simple. We have to prepare the extract and mix the zinc salt in the extract, maintain a pH, and stir it for say sometimes for 4 hours, 5 hours, or relatively longer or shorter depending upon the reaction conditions. You have a color change, a visual changes seen, and then afterwards this synthesis of zinc oxide nanoparticles is being done. Now, for characterization of the synthesized zinc oxide nanoparticles, various other techniques were used. The first one is XRD. X-ray diffraction pattern of uncoated zinc oxide nanoparticles shows 2 theta values at 31.8 to 34. And the strong and broad pattern of diffraction peaks of uncoated zinc oxide nanoparticle confirms the presence of a hexagonal woodsite structure. Also, in the case of calcium-coated zinc oxide nanoparticles, hexagonal woodsite structures is maintained. In other study, we all where potato starch mediated synthesis of zinc oxide nanoparticles. Again, this hexagonal woodsite structure of zinc oxide nanoparticle is maintained. The XRD pattern also shows that prepared calcium nanocomposites of zinc oxide nanoparticles also have hexagonal woodsite structure. And the next is the characterization through FTIR, where this FTIR analysis were done to identify the natural molecules responsible for reducing and efficient stabilization of the zinc oxide nanoparticles. It also provides information that the formation of zinc oxide nanoparticles due to interaction of phenolic compounds, alkenes, terpenes, and flavonoids. Broadband around 34-3500 shows the presence of hydroxyl group indicating various terpenoids or alkaloids present in agricultural waste. It confirms its involvement in the reduction of zinc 2 plus ions into zinc oxide nanoparticles. The sharp peaks in between 450 to 630 are due to this zinc and oxygen stretching band. Now, the morphology and composition were characterized through SEM, HRTM, and ADX analysis. In one of the studies, the TEM showed that the size range of the nanoparticle synthesized were in between 20 to 100 nanometer, and with calcium coating, this size increases. And morphology, we have seen clusters where spherical shape of zinc oxide nanoparticles to somewhat bean-shaped zinc oxide nanoparticles we have synthesized. And EDX studies gave the elemental composition of zinc oxide. And now coming on to the photodegradation studies of synthesized zinc oxide nanoparticles, we actually did the degradation studies on two dyes. One is methylene blue and other one is rhodamine B. But I'm not showing. I'm showing only the degradation study of methylene blue only. See. Photocatalytic reactions involve electron hole pair formation by semiconductor nanoparticles. When irradiated with sunlight, the absorbed photons can cause electrons to be excited from valence band to conduction band to produce an electron and a hole. These species then generate oxidative species
Yeah,
after.
exceeding time, Dr. Amar.
Yes, ma'am. The main thing that I
Yeah,
want
just
to show.
tell us in nutshell, your achievement and your, what is the success point which you have achieved in this.
Okay, ma'am.
Okay.
This is the effect of zinc oxide nanoparticles in and its calcium nanocomposites on photodegradation of methylene blue dye under natural sunlight. Synthesized zinc oxide nanoparticle demonstrated high photocatalytic activity with almost 100% degradation of methylene blue dye within 40 to 50 minutes. Photocatalytic activity increases with calcium coating when the ratio was around 2:1. But further rise in calcium concentration did not when we raised the ratio to 1:1 ratio. The activity didn't increase to further extent. Now, antibacterial studies on zinc synthesized zinc oxide nanoparticles showed that these synthesized zinc oxide nanoparticles are effective in inhibiting the growth of bacteria.
Please go to conclusion slide, please.
Okay, ma'am. The conclusion is that zinc oxide nanoparticles and calcium-coated zinc oxide nanoparticles offers promising technology for the removal of pollutant dyes from wastewater. They are relatively inexpensive, easy to produce, especially through plant-mediated process using a wide variety of plants and plant parts, and effective at removing a wide range of dyes. Zinc oxide nanoparticles were also shown to be effective against disease-causing bacteria. One of the main advantages of using zinc oxide nanoparticles for dye removal is that they are relatively non-toxic and biodegradable. This means that they are less likely to cause harm to the environment than some other dye removal methods. However, it is important to note that zinc oxide nanoparticles can be toxic to some aquatic organisms at high concentration. Thus, more research is needed to optimize the use of zinc oxide nanoparticles for dye removal and to address potential environmental concerns. I would like to acknowledge all my co-authors and especially Dr. Darshan Singh, Associate Professor, Department of Chemistry, Daulat Ram College, University of Delhi, and Dr. Lakshman Singh, Associate Professor, Department of Chemistry, Siddharth University, Kapilvastu, and Daulat Ram College, where I used to work as an ad hoc between 2012 and 2017, and Ramakrishna Dwarka Mahavidyalaya, Patliputra University, where presently I am posted. Thank you, ma'am.
So, Dr. Amar, good to see you on this platform, and it was a good presentation. Now I can recall when you said, after so many years, now I'm very sure that I can, all the memories are. Now my point is here.
Yes, ma'am.
Before I ask any question from the audience? I'm looking for at least one question from the audience. No one is coming forward. Okay. So there has been lot of work done on this zinc oxide particles. So what is why you want to pursue in this particular area? Why you are not taking any other particle? Why only zinc oxide particle? Because a lot of literature is available. So I don't.
Yes, a lot of literature is available, ma'am.
I don't find any, novelty or plus points in using this technology. That's so please justify your work.
Ma'am, there are many reasons on this to work. I'm trying to work on the zinc oxide nanoparticles because the place where I am working I'm basically I'm trained to be a organic synthetic chemist. Okay, and I'm shifting this my field to nanochemistry because there are certain constraints here,
Okay.
and I want to first try those areas which has been established. So I have, at least I must have some literature results to work upon a new area, first thing. And second thing, the precursors are relatively cheap. And I want to work upon some nano composite area. I want to this use this uh, uh, loads of literature or the information that is available to synthesize some nano composites. So at least I have that part of literature where I am confident. And I
Okay.
have information, you know. So that's why. And this major work of this which I have shown is has been done at Daulat Ram College, and Dr. Darshan Singh and all are, I used to work there as an ad hoc, and
No, it's a good piece of work, and that's what I wanted to know. And I wish you all the very best.
thank you, ma'am.
Okay, okay. So let's give a big hand to Dr. Amar. Our next presenter is Dr. Khem Raj Meena. Dr. Khem Raj Meena, is he around? Has he joined? Dr. Khem Raj Meena? If he is not there, okay. If he is not there, then our next participant is Dr. Anil Kumar. Dr. Anil Kumar? Dr. Anil Kumar?
Ma'am, he was there, but now I think he has left.
Okay. So we can go ahead with the next one. Can we contact them?
Let me try, ma'am.
Okay. Meanwhile, let me go ahead with the Dr. Neeta Azad. Dr. Neeta Azad. Has she joined?
No, ma'am, she has not joined.
Okay. Our next candidate is Dr. Sakshi Sharma. Dr. Sakshi
Yes, ma'am.
Sharma. Dr. Sakshi Sharma.
Yes, ma'am. I'm present.
Okay.
Yes.
Okay. So, Dr. Sakshi, welcome on this platform.
Thank you so much,
This
ma'am.
conference, ICHE-2023. Pleasure to have you on this online platform, and I request you to please introduce yourself.
Yes, ma'am.
And go
Ma'am,
ahead with your
presently,
presentation. Yeah.
yes,
And
ma'am.
your time limit
Presently,
is
8 minutes, ma'am.
7 to 8 minutes. Yes.
Yes, ma'am. Yes. Presently, ma'am, I'm working as an assistant professor at the Department of Botany at DAV College, Amritsar.
Okay.
And today, just let me share my screen. Just I'll take 1 minute only.
Okay.
Ma'am, is it visible now?
Yes, it's fine.
Yes, yes, ma'am. So, ma'am, today I'm going to present my meme in some soils and wheat grains and associated non-carcinogenic health risk posed to the human population of Rupert wetland and its surroundings. So, there is some problem with this. Okay, so as we all know that the soil is both source and sink of heavy metals for plants, and the major roots for contamination of soils is inefficient disposal of both solid and liquid waste from industrial, domestic, agricultural setups, and also the excessive irrigation fields with the contaminated water and application of fertilizers and pesticides which are laden with chemicals. So accumulation of these heavy metals
Just a
in
second.
both soil.
Just a
Yes, ma'am.
And Dr. Rita is there. Dr. Rita?
Ma'am? Yes,
Yeah.
ma'am.
Yeah, Dr. Rita, this presentation is from the botany department. I request you to kindly please listen to this presentation. I am also here. Okay.
Okay. It's not
Okay.
part of chemistry, ma'am.
Yeah, it's not part of chemistry. She's from the department of
Ma'am,
botany.
actually,
Yeah.
it's a environmental monitoring study along with its health impacts.
Okay. Okay.
Yes, ma'am. So, ma'am, should I continue?
Yeah, please go ahead.
Yes, ma'am. So accumulation of these heavy metals in both soils and food crops today has become a grave problem all over the globe. And wheat is one of the staple foods we consume on daily basis. So if the wheat cultivation is getting contaminated with cadmium, obviously it is a matter of worry for human beings, because these heavy metals, they enter into food chain and then they affect the human bodies if we are exposed to these for a long term. So this is a little bit of introduction about the study area. So Roper wetland is a Ramsar site. So it has a huge biodiversity value, and it is situated on the banks of River Satluj. Study was conducted in this area particularly because though it is declared as a Ramsar site, but the irony is that it is surrounded with industrial, domestic, and agricultural setup. So it is hugely exposed to human interference. So keeping all these facts in the mind, we decided that we will assess the cadmium content in soils and wheat grain samples, and then we will go for estimation of non-cancer human health risk. So this is the work plan. We firstly surveyed the area and then we selected some sampling sites. Samples were collected, and then for soil samples, we went for physicochemical analysis followed by estimation of cadmium content. Whereas in case of wheat grains, we directly went for cadmium content estimation followed by estimation of bioconcentration factor and possible non-carcinogenic health risk assessment. Whole data was analyzed descriptively. This is the map of study area showing different sampling sites. And this table shows us the geographical coordinates of the same. In case of soil analysis, we brought the samples to lab, then we cleaned, air dried, and sieved them, followed by storage. And for soil texture, we used the soil samples as such, but for pH and DC, we went for preparation of soil extracts in distilled water. And then for estimation of cadmium content, we used aqua regia method of digestion followed by atomic absorption spectrophotometry, and the data was analyzed descriptively. These are the results for analysis, and it is evident from these that soils were alkaline and non-saline in nature, with the texture ranging from sandy to loamy sand. When we talk about the cadmium content, all the soil samples had cadmium content above the typical soil concentration level. Then when we went for the wheat grain analysis, we washed them with distilled water, oven dried, and they were ground to fine powder and stored till analysis at 4 degrees Celsius.
Your
And when
slides
they,
are not moving.
ma'am, should I share the screen again? Maybe then they will move.
Yes.
Uh, uh, Ma'am, is my screen visible now?
No.
Okay, I don't know what is the issue with this, because I am sharing the screen. Uh, ma'am, is it visible now?
Yeah.
Okay, but I think these are not moving or something. Ma'am,
Yeah.
so
Yeah.
ma'am, this is the slide I was on.
Yeah.
Okay. So when we went for the wheat grain analysis, we did the digestion with dry acid mixture method, and then atomic absorption spectrophotometry was done for the same, and the data was analyzed descriptively. So to the results, we see that cadmium content in all the wheat grain samples was below the permissible limit. So it sounds safe, but when we look into the further analysis, that is bioconcentration factor analysis, it just gave us a whole different story. So firstly, what is BCF? So BCF, or bioconcentration factor, is the content of a heavy metal in wheat grains. When we divide it with the content of same heavy metal in the corresponding soil sample, we get a BCF value. And a plant is considered as an accumulator for any specific heavy metal only if the BCF value is greater than 1. So in this study, it was observed that at least 44% samples of wheat grains were having BCF value greater than 1. So this prompted us to go for this assessment of non-cancer health risk. For that, we followed the UCPA guidelines. And firstly, we went for the estimation of daily dietary intake of cadmium. There is some noise.
Yeah, there is some noise. Let me check.
Okay, ma'am, I'll continue, ma'am. So firstly, we determined DI using the formula as shown in the table. And then after that, we went for the estimation of non-carcinogenic health hazard question, for which we required the reference dose of cadmium given by UCPA. And the value for a reference dose was 0.001. So how we interpret the result is that if HQ value is greater than 1, then there is some risk for non-carcinogenic health problems. And these are the results we obtained for the study. It was seen that DI value ranged from 2.69 to 5.05 into 10 raised to power 3 mg per kg per day. It itself does not give us much idea about the risk, so we have to go for HQ estimation, and we found
Akshay, please mute yourself.
Yes, ma'am. So this is the slide I was showing. So the values ranged from 2.69 to 5.05. Obviously, all the values are much higher than 1. This indicated that there is health problem in the study area, or it will occur in the future. So if I conclude the study, firstly, all the soil samples had high cadmium content. Wheat grain samples had less cadmium. They seemed safe, but when we look into BCF values, 44% samples are showing us that there is huge accumulation of cadmium in wheat grains. So when we go into the further study, we see that hazard quotient is also there. And for all the wheat grain samples, HQ was higher than 1. So we have to tackle this problem. And the baseline thing will be, firstly, we have to control the soil pollution. And for that, there are so many strategies, but I will be suggesting that firstly, we can follow the rules and regulations which are designed by the government for disposal of these domestic and industrial waste. And then we can also apply some strategies.
Dakshesh, please mute yourself. Dr. Dakshesh, please mute yourself. Dr. Rita, please tell him. He's talking over phone.
Yes. So when we apply some strategic techniques like phytoremediation, we can elevate the levels of cadmium in soil. So I would like to acknowledge the University Grants Commission for funding this study under UP scheme. These were some references I used for this presentation, and this was the paper published where from which I have taken this presentation. Thank you so much, ma'am. Thank you for giving me the opportunity. Thank you.
So Sakshi, Dr. Sakshi, yes.
Yes,
it was good work. Any comments, any questions from Dr. Rita? If you are around. Dr. Rita is around?
Yes, ma'am.
Yeah. Any question, any comment, compliment on her work? She has done good piece of work. If no, then let me thank Dr. Sakshi.
No, ma'am, it's not my field.
Okay.
So I don't have any questions.
Okay, okay. So let us thank Dr. Sakshi for wonderful piece of work and for your presentation. I wish you all the very best.
Thank you,
Our
ma'am.
next presenter is Dr. Rekha. Dr. Rekha is, yes, she is there. Dr. Rekha Sekar. Dr. Rekha, please unmute yourself. She is not responding. Dr. Rekha.
Hello.
She is not responding. I think I have received one message from Dr. Anil.
Yes, ma'am.
Yeah.
He is there, Dr.
Okay.
Dr. Anil.
So let's take Dr. Anil. Okay, Dr. Anil, please unmute yourself and
Yes, ma'am. Hello, ma'am. Yeah, hello, ma'am. Am I audible?
you are audible.
Hello.
Yes, you are audible. Please introduce yourself.
Okay, ma'am.
Hello, sir. Hello.
Yes, Dr. Rekha.
Yeah, ma'am. Yeah, ma'am.
Yeah, अभी Dr. Anil कर रहे हैं. After that, you were not there. I called your name.
Okay. Okay, ma'am. Okay.
Okay, so wait for Dr.
Okay.
Once he completes, then you present.
Okay, ma'am.
So, Dr. Anil, what happened? Dr. Anil, please introduce yourself.
Hello, ma'am. Hello, ma'am. Dr. Anil. Hello, ma'am. Hello.
Yes.
Hello.
Dr. Anil. He's not there. I think he's not able to join.
Dr. Anil, please share your screen.
The-
Is he using the Dr. Dakshay Sharma screen?
Actually, ma'am, he called me. Then I have joined with name Dakshesh Sharma,
Okay.
and I am Dr. Anil Kumar.
Okay.
But I think some connection problem.
Yeah, some connection problem. In
With
fact,
his side.
Dakshesh was disturbing too much in the beginning.
Yes,
in the
ma'am.
presentation. Also.
So can we move to another
Yeah.
presentation?
So,
Yeah.
Dr.
Presentation. Yes, ma'am. Is it visible?
No.
Hello.
No.
Hello.
No, not visible.
Not visible. Okay, it is loading, madam. Loading. Yes.
Yes, it's visible now.
Okay. Can I start, ma'am?
Yes, please go ahead.
Yes, I'm sorry, ma'am. Actually, there is the internet was disturbance is quite from the morning. So this is I am Dr. Anil Kumar from Shri Mata Vaishno Devi University, Katra. So I'm here as an assistant professor working, and this work actually is in collaboration. I actually visited the US as a postdoctoral fellowship recently. So I did there in the Texas A&M University, and I'm continuing that work here also. So this is the title of my work, that enantioselective synthesis using trace 1,2-diphenylethylene diamine cobalt third complexes. So these are commonly, we know these are the cobalt complexes or octahedral complexes. They are commonly called as Werner complexes because most of the work on these complexes has been done by the Werner. So we can see that these two complexes, octahedral complexes of cobalt, actually exist in two forms. Actually, this is lambda form and delta form, and these exist in, these are actually enantiomeric form. So chirality of these complexes is due to the metal center here, cobalt in 3 oxidation state. And the important thing about this that these complexes does not resomerize at room temperature. So these are also separated very easily by the fractional crystallization with chiral anion like tartarate anion. Despite
Again, is disconnected. Hello. Dr. Rita, are you there?
Yes, ma'am. Dr. Anil, you are not audible.
hello,
Yeah, you're
hello.
Now audible.
Okay, ma'am. So why these complexes have been overlapped in organic synthesis? Because the substrates cannot access the metal line. Metal, this can be the one reason, and another that these complexes are not soluble in organic solvents. So these are two challenges which come.
again, it has been disconnected.
I think, Dr. Anil, there is some connection issue from your side.
These are all participating in catalysis using their forming hydrogen bonds. So although the cobalt is at the not participating directly, but these NH2 group can participate in catalysis. So this is a one number challenge. Second challenge, that the cobalt complex is not soluble in water. So that can be solved by replacing this. The counter anion iodine can be replaced by this bigger lipophilic anion that is commonly called as Borf anion. When we replace this iodine or any counter anion with this bigger molecule, what happens? These complexes which become soluble in organic solvent. So Na and I is in aqueous condition, and now this complex becomes soluble in organic solvent. So this work has been done in Gladys group in 2008, and they have then used this catalyst first time for the reaction of Michael reaction. And yes, the catalyst work for this Michael reaction, and 78% yield was obtained. However, the enantiomer selectivity of these complexes were very low. But the important observation is that yes, these complexes catalyze the reaction, and this is due to the NH2 group. That is, they participate in catalysis through hydrogen bond. So the next is that since the catalyst is working, so now they try to make more complexes by using different ligands. So they use this 1,2 di
So, Dr. Anil, not able to hear you.
Yes.
Not
Yes.
able.
Hello.
Yeah, it's going, coming all the time. It's disturbing too much.
Yes, ma'am. This is not.
Slides are also not moving. I think you can go directly to the conclusion slide.
Okay, ma'am. So, madam. Okay, ma'am. So we have done this reaction also. So many.
I know it's a good piece of work. Okay, you
Yes.
have done a lot of work, but due to some, connection problem,
Yes,
we
ma'am.
are not able to.
Yes. Yes, ma'am. Enantiomers we know very important as biological activity is reside in one enantiomer. Werner salt can easily be solubilized in organic solvent, and this can easily be rendered enantiopure. So therefore, these are the significant new addition to the chiral pool. Recent one, just 10 years ago, they have been used as a catalyst. So there are unique array of hydrogen bonding bond atoms versus thiourea. Thiourea contain 2 NH group. Here we have 12 NH hydrogen atom that can give rise to additional chemistry, new catalysis, etc. Similarly, chiral Werner salt have enormous stereochemical diversity, and they are easily rendered bifunctional. Bifunctional can be used basic functional group will also be used. So concept can be extended to cationic coordination compounds with ligating NH-PH moiety subsequently, and this will be investigated in the new reactions, madam. This is actually work I have been sponsored by UGC under Raman Fellowship, and Well Foundation grant is the USA and Department of Biotechnology. They also sponsored actually this trip. So this is all about, ma'am. Thank you very much. And I'm sorry for the internet is not working fine. Hello.
Yes.
Yes, ma'am.
So I think I could not follow much. In fact, it's a work of my interest. I wanted to listen to you, but there was so much disturbance.
Yes.
And it's a collaborative work, and at that place with what you are doing, it's a great work. And no questions right now. Okay. And thank you so much for
Thank
being
you.
with us. And I wish you all the very best for your future endeavor.
Thank you, ma'am, for
Yeah,
your cooperation.
No, I
Thank you,
understand.
ma'am.
Technology has the benefits as well as negatives also. There are drawbacks also with this technology. So next speaker is Dr. Lekha.
Hello, ma'am. Good
Yeah.
evening.
Yeah. Please remove your slides, Dr. Anil. Please unshare your slide, Dr. Anil. Dr. Anil, please unshare your slides. Yes, Dr. Rekha, you may start, please.
Sure, ma'am. Sure.
Please introduce yourself. Welcome on this platform of ICHE-2023.
Ma'am, I'm Rekha. I'm Dr. Rekha. I'm working as an assistant professor in St. Joseph College of Engineering, Chennai. I'm from Tamil Nadu, ma'am.
Okay. Welcome here and start your presentation.
Sure.
Your time limit is 7 to 8 minutes.
Okay. Just a minute, ma'am.
Okay.
My research title will be Nonlinear Boundary Value Problem and Tubular Bioreactor for Industrial Wastewater Treatment. My research guide will be Dr. L. Rajendran, sir. And introduction of the subject. Nonlinear partial differential equation describe tubular bioreactor dynamics. The kinetics term causes the nonlinearity. On the mass balanced principle, the dynamics modeling is established. The study considered a tubular bioreactor where only one microbial reaction. Taylor series and Akbari-Ganji methods are used in this particular model, ma'am. Both are solved numerically and analytically with appropriate boundary conditions. The effects of material parameters on industrial wastewater treatment of tubular bioreactor system are also discussed. Purpose of the study is our analytical results are compared with the previous result. The effect of various values of industrial wastewater treatment of bioreactor have been computed and shown graphically. Literature survey. In the past 30 years, the analysis of tubular bioreactor is essential because it enables the classification of most real systems into thoroughly mixed systems and perfect plug flow systems characterized by their hydrodynamic behavior. No research has previously been done on the issue of numerous stable equilibrium profiles in tubular bioreactor for a broad range of non-monotonic kinetics and convection dispersion systems. The fact that the current study was conducted without assuming a specific kinetics formula, instead used qualitative research to gather more general and generic data on the system's behavior is a crucial problem. This is the model. The kinetic adjusts to the Monod law. Therefore, using the diffusion, convection, and reaction model, we can put the process dynamics in dimensionless form as follows. This is a second order nonlinear differential equation. This is the
Your slides are not
model.
moving.
Ma'am?
Your slides are not moving. Please make it on the, F5 slide share mode.
Ma'am, it will be in F5 mode only, ma'am. I have showing my
But it's
mathematical.
not moving.
Shall I stop and reshare again, ma'am?
Yes, please. Yeah,
Is that
it's fine.
visible, ma'am?
Yes.
This is the already existing method. In this method, we solve numerically and analytically, and we have compared both numerical and analytical value by graphical methods. Here, the analytical method which we are using is Taylor series method and Akbari-Ganji method. Here, P is nothing but the Pecklite numbers. This is the result of our analytical result. First one is the result of Akbari-Ganji method. Second one is the result of Taylor series method. Compared to Akbari-Ganji method, Taylor series method, in Taylor series method, the result will be converge easily. This is the graphical presentation for various values of the parameter. This is the table value for various values of the parameter for both the Taylor series method and Akbari-Ganji method with numerical values. Here the numerical tool we are using is MATLAB OD45. Thank you.
Okay, thank you, Dr. Rekha.
Thank you.
It was quick presentation. Just in one line, your positive points about your work, if you can say.
Ma'am,
What is your achievement in one sentence, if you want to?
Actually, in this problem is related to the industrial wastewater treatment by using the tubular bioreactor. By this model is already existing model. We just applying the analytical and numerical method to see the variation by changing the parameters.
Okay, okay, okay. So thank you very much.
Thank you.
So let's give big hand for Dr. Rekha for her good presentation. Any other participant or presenter who has been left and could not join earlier? I'll be happy if he or she wants to present. No. So if no more presentations, it's time to conclude this session. We had we have 8 presentations in all, and all presentations were really good. They were diversified in different areas, starting from chemistry to plant physiology to environment to fly ash, different biodegradable polymers, covering all aspects. So we can say that this session was interdisciplinary in nature, and I hope all the audience have enjoyed this session and they have, there is good take home food for them. So I thank you all the participants and wish them all the very best. I thank Dr. Rita for coordinating well in this session, and all my best wishes.
Yeah.
Okay.
Yeah. We also would like to thank you, ma'am, for taking out time from your busy schedule for this conference. And sorry for the inconvenience caused due to unwanted things.
No,
So
I
we are-
understand that it's big conference. There are so many problems associated every time. I understand. That's
Yes.
fine. And I wish you all the very best.
Yeah,
Thank you so
ma'am.
much. Thank you.
Yes. Okay, thank you. Thank you for all participants. So we are ending this session now.
Yeah, we are. Bye.
Thank you. Bye, ma'am. Thank you.